So this is what should be a fairly quick and straightforward screencast on the classification of matter. As you can see, we have a flow chart here that kind of goes through it pretty self-explanatorily. I'm going to go through it anyway with you. First step in classifying matter is, well, is it a substance, a pure substance, or is it a mixture? Alright, pure substance or a mixture. This is kind of like a dichotomous key. We're breaking it down according to its characteristics. The two most broad categories are pure substances or mixtures. Let's start with the pure substances. They're homogeneous, which means they're uniform throughout. All right, they're made up of a definite composition, and they're not physically separable. You can't break them up. If it's a pure substance, you should have the periodic table in mind, because it could be an element, which means it has only one type of atom, or it could be a compound. And when we're talking about elements, let me get my cursor out here. If we're talking about elements, we're talking about one particular atom. We're talking about hydrogen, or oxygen, or nitrogen, phosphorus, sodium, you name it. If it's on the periodic table of elements, obviously that's an element. Compounds are two or more types of atoms chemically bonded together. Immediately, most of us would think of water. Hydrogen and oxygen, two different types of atoms bonded together. Salt, NaCl, two different types of atoms bonded together. These are pure substances. All right, one type of atom, two or more types of atoms. Two or more, by more it could be H2SO4. There's three types of atoms, but it's a compound. Now, if it's not a pure substance, it's a mixture. That means it's two or more physically separable components, so you can separate them out. The mixtures could either be homogeneous, which is uniform throughout at the top of the sample, or at the bottom of the sample. It's going to be the same concentration. It's not going to be stronger at the bottom or stronger at the top. Homogeneous mixtures are also called solutions. Alright? They're also called solutions. When we think of homogeneous mixtures, we're thinking of salt water. We're thinking of Kool-Aid. Uniform throughout. Your first drink tastes just the same as your last one. They're not going to be stronger. If you take a sample from one part of the solution, it's going to be the same concentration as another side of the solution. While we're on the subject of solutions, the substance that gets dissolved in the solution, remember that's the solute. Alright, I'll put that just down here as an aside. And the solute gets dissolved in the solvent. Again, just as an aside. Going back to mixtures, if they aren't uniform throughout, we call them heterogeneous. They might have chunks floating in it. The example we always use is the salad dressing, the Italian dressing. We know that before you put the delicious Italian dressing on your salad, you got to shake it up, get all that stuff mixed in, because it might be all floated, or it might be floating on the top, or whatever it might be. Heterogeneous mixtures will settle often. They have substances in them that might settle out. Depending on the size of those substances, heterogeneous mixtures could be a colloid, or they could be suspensions. Colloid have very, very small substances here. Microscopic particles. These are things like milk. We talked about milk going through homogenization, so the very small fat globules are floating in the milk, but they're very, very small. Suspensions, let's underline this word large. They have larger substances floating in them. Salad dressing would be a suspension. Okay, if you go to the beach and you have a bucket and you have sand in your water and it's all cloudy, the sand is a large substance and it's suspended in, it'll settle out because it's heterogeneous. It's not mixed in like salt water would be or like Kool-Aid would be. And that's basically it for the classification of matter.